The FiberSense's FD322 alarm processing unit, otherwise known as an APU, is an economical optical fiber-based intrusion sensor that's been designed to detect someone trying to climb over or cut through a chain link fence that surrounds a protected area. This presentation will serve to provide information regarding the product's capabilities and how to use it. The topics of discussion include the product's features, its applications, how it works, the features and operation of the software that's included with each unit, and product installation, calibration, tuning, and maintenance. Let's start by discussing the product features. The sensor will support a maximum sensing cable length of 500 meters per channel, and there are 2 sensing channels per unit. For all practical purposes, the APU will support all normal zone lengths. Now, the FD322 operates in what's known as the loopback mode. This means that the sensing element starts at the FD322's optical output connector, then loops back to the optical input after traveling its path on the fence line. This translates to a 250-meter linear piece of fence line covered per channel, and since the FD322 has 2 sensing channels, a total of 500 meters of fence line can be monitored by each APU. In practice, fence zones are rarely longer than 250 meters, so the FD322 is well equipped to handle 2 such zones. The sensing fiber connects directly to the processor with no option for using insensitive cable to separate the unit from the protected area. The APU must therefore be located at the fence line or very close to it. The unit comes equipped with 2 separate means of connection to alarm monitoring hardware: an Ethernet-based TCP/IP communications channel, and standard alarm relay outputs. Both of these will be discussed in detail later on in this presentation. Also included is user software that allows the processor to be set up, tuned, and maintained. As mentioned earlier, the FD322 is fiber-based. The sensing element therefore possesses 2 important features: immunity to RFI/EMI, and intrinsic safety. Both are due to the fact that the sensing element is inert and non-conductive. For example, if lightning strikes the fence or somewhere nearby, the processor is protected since none of that energy can possibly be carried back to the unit. Also, the RFI and EMI transients that routinely cause nuisance alarms on other intrusion sensors are simply not an issue, again due to the non-conductive nature of the fiber. The sensing element is also intrinsically safe because, since it carries no electrical current, it cannot possibly create a spark. It is therefore safe to pass the fiber through explosive atmospheres that may be found at petroleum refineries, chemical plants, and similar sites where copper-based sensing elements are simply not usable. The FD322 is value-priced, being our most economical fiber sensor. Its low cost and high performance make fiber optic sensing available to new market segments that previously could not afford such products. The sensor is simple to install and adjust. It has an efficient yet powerful set of tuning parameters that make it possible to detect those intrusion attempts that need to be detected while rejecting the nuisance alarm sources that need to be rejected. The FD322 has the capability of internally storing data records that contain detailed information related to the most recent 24 alarms registered by each sensing channel. This is not a simple time and date stamp record. Rather, it's highly detailed information that includes an oscilloscope-type analog waveform plus a frequency domain representation that identifies the spectral content of the events. This information can be downloaded from the processor and analyzed with the tuning software to enable improved detection and nuisance alarm rejection through parameter adjustments. The unit will operate over a wide temperature range from -40 to +70 degrees Celsius. Finally, the unit is CE and RoHS compliant, meaning that it will operate reliably and safely under all normal conditions and that it contains none of the 6 extremely hazardous substances identified by the European Restriction of Hazardous Substances Initiative. Now let's go over some product application concepts. First, the product is specifically designed for chain link fence protection. It's been designed for mounting at or near the fence line and is typically placed in a NEMA enclosure to protect it from the elements. And it's been designed to use our standard SC3 sensing fiber and conduit in a loopback configuration. Consider first the sensing element shown here in red. It starts inside the enclosure at the APU's optical output, exits the enclosure, and is mounted on the fence, and then loops back to the unit's optical input. A second sensing element, shown in blue, starts at the same processor's other channel and goes off to the left. And at the far right, an overlapping zone from the next APU can be seen, also in blue. This scenario represents a typical FD322 application example. There are many potential application sites for the FD322. Let's briefly mention some of them here, starting with utility substations. The perimeter of a manufacturing plant can also be protected, as can be corporate buildings, construction sites, boat and RV storage sites, and garden centers. These are but a few of the potential sites where the FD322 can be used to gain protection from the bad guys. Now let's briefly discuss the APU's connectivity features, starting with the electrical terminal connections. The photo on the right here shows the unit's 12-pin terminal block to which all of the electrical connections are made. We'll start with the alarm relay contacts, terminals 7 through 12. Each APU channel has a set of Form C relay contacts. Take the channel B contacts, terminals 10 through 12, for example. Pin 11 is the common terminal, while pin 12 provides a normally open relay contact, and pin 10 is the normally closed contact. Channel A has an equivalent set of contacts on pins 7 through 9. Next, terminals 5 and 6 provide a set of normally closed fault contacts that open when any of a number of potential trouble conditions occurs. These include a loss of optical power due to a sensing element cut or a sharp bend in the fiber, or an internal electronic fault such as a deteriorating laser or other circuitry. All of these relay contacts have been implemented with solid-state devices, and as such, they inherently have low power ratings. They are capable of handling a maximum of 100 milliamps at 12 volts DC. They don't have the capacity to drive sirens or floodlights directly, although they can be used to trigger higher power relays and other devices. These contacts are primarily designed to interface with alarm control panel inputs to facilitate alarm monitoring. Next in line, terminals 3 and 4 provide a tamper input function that accepts inputs from a normally closed tamper switch that is physically operated when the APU's NEMA enclosure is open. When this occurs, the alarm relays signal the monitoring system to notify it that the APU is being tampered with. Finally, terminals 1 and 2 provide the power input to the APU. It will operate over a 12 to 24 volt DC range, and at 12 volts DC, the unit will draw a maximum current of 250 milliamps, corresponding to a maximum power consumption of 3 watts. The other form of connectivity that comes standard with the FD322 is an XML-based TCP/IP scheme. This is implemented through an RJ45 Ethernet jack that's located on the APU's left side panel. IP connectivity provides the abilities for remote alarm and fault monitoring and for remote APU parameter setting. The unit is plug-and-play compatible with Fiber Commander, a low-cost, PC-based head-end software solution that's optionally available from FiberSenses. This concludes our discussion of the FD322's basic functionality.